It's time to rethink about the word inheritance. When you think about this, maybe you think about something you get when somebody dies. In programming, it's a way to define at a higher level variables, functions, and functionality that your child classes can inherit and override from the parent class. We're going to get into what all of that means in this video. Hey, Chris here from LlamAcademy, here to help you.
Who, me?
Yes, you! Make your game dev dreams become a reality by redefining what the word inheritance means. When we talk about inheritance in programming context, we're not talking about your eye color, your hair color, or the sum of money you get when one of your family members passes away. In programming, when we're talking about inheritance, it's not exactly the same thing, but we use a lot of the same terminology. For example, you might say, oh, I inherited this hair color, or my eye color, or my very fancy fingers from my parents. We're going to use really similar terminology, and it starts making sense once we get into what are we inheriting from our parents. And actually, we've already been using inheritance the entire time that we've been writing any code in Unity at all, because all of our classes extend or inherit from the monobehavior class. Anytime that we want to define a new script that we're going to attach to a game object in Unity, we're using inheritance. Whenever we're talking about this kind of a relationship of a parent to a child, the parent is the monobehavior class that defines some functionality, some variables that we want to pass on down to our children. The child class that we're implementing is our new behavior that we want to implement to do some specific game logic. We'll call our new behavior the child, or the subclass, or a derived class. All of these mean the exact same thing. It means the class that's a child of the parent that subclasses that parent class. A couple of other really important terminology notes here is, one, you can only have one parent class for your child class. Unlike real life where you generally need two parents, we can only have one in C#. If we try to extend, that's what we call subclassing or creating a child class. We're saying we're extending that behavior. If we extend multiple parent classes, we'll get a compiler error. The C# compiler will tell us we can't do that. You can only have one parent class. So whenever you're subclassing something, make sure you're only picking one parent class. One thing you can do is implement multiple interfaces. I know we haven't talked about interfaces really in the series. We're going to today, but that is a key distinction, that an interface is distinctly different from a parent class. We can extend one parent class, but implement multiple different interfaces. That's okay. Now, I know this probably sounds really abstract and maybe your eyes are glazing over because you're like, well, this guy's getting too technical for me. I don't really know what he's saying. Let's break it down with a real life example. Let's say that we want to do some kind of data modeling to represent in our game a car. Whenever we start thinking about a car, we need to think about what components go into a car. Maybe it has some wheels, it has a windshield, it has some seats. You'll notice that I'm saying has a bunch of times here because this is what we call a has-a, or a compositional relationship. And all that means is we're giving properties to this class. So we'll put into this car a bunch of properties that define and everything that we can think about that makes up this car, right? We'll say this car has all these different things. We'll also define some functions to say we can drive the car, it can maybe start, it can brake, it can accelerate. All these things that a car can do would be defined as functions on a car. Once we've fully defined, I'm really confident this is what a car can do. Let's say that we think about it and you're like, maybe we want to add a boat to our game. Now we start thinking about, okay, boats and cars have some similar properties. A boat also has some seats. A boat also has an engine. A boat also has a body, let's say. We start to see there are a lot of similarities here, right? The boat can also steer. The boat can also accelerate. It can also slow down or stop. Maybe at this point, we don't want to copy paste what we have from the car into a boat, because then what happens when I need an airplane? It has, again, all the same kind of things. It would then be convenient to put all the things that are common across all of these into one class and have all of our subclasses. Now you're seeing where I'm going with this. The parent class, maybe we call it motorized vehicle. It has all of these things about an engine, a body, it has functionality such as start, stop, accelerate, decelerate, all these kinds of things we can define at a motorized vehicle level, and then implement the specific functionalities and differences in the subclass. So then the car can have wheels because a boat maybe doesn't have wheels. I think you're getting the point. There's a lot of ways you can go with this data modeling perspective of object-oriented programming where classes are defining objects. This is what I'm trying to get at. The parent class defines generalized functionality that maybe we have different subclasses that have specialized functionality. If we relate that back to our mono behavior we were just talking about, Unity has defined a bunch of behavior that any mono behavior needs or could maybe want to do. And then for your specific game, you're creating a subclass of the mono behavior to implement your specific game logic. Now that we've talked about that parent-child relationship, let's talk about what is an interface and how do we define an interface. Because remember I said this is distinctly different than having the parent-child relationship. First, the key difference is whenever you're defining an interface, you define a public interface, and then whatever you want to call the interface, we usually start that with an I. So in some of my videos you might have seen I defined a damageable interface. So I did public interface, I damageable, indicating that this is an interface, just by the class name. And in there we define everything that we think that a damageable object should be able to do. For example, maybe damageable has some life, maybe it has a take damage function, maybe it has a die function. Some key points here is the health must be a property, not a field, meaning we need a get and setter inside of it. And those functions must be public. They're public by default. If you specify an access modifier, it complains at you. So you just write the return type, name of the function, arguments, and you do not define a body. So you're just defining this is the things that you can do, and anybody who implements that interface has to implement those specific functions. Let's bring real life into the picture again, because what I just said probably is still a little bit abstract. Let's talk about your phone. Almost everybody has a phone nowadays. You have iPhone, Android phone, most likely one of the two. How you plug in your phone is an interface. So on the iPhone, it uses the Lightning port. On an Android phone, it's using a USB interface of some kind. So your phone manufacturer had to implement that interface and handle what happens when you plug it in. There's like 4 or 5 different modes of plugging it in. You can only charge the phone, you can do file transferring, you can tether, you can maybe hook up to a car. There's some other stuff, whatever all your phone can do whenever you plug it in. Your phone manufacturer, and probably the operating system provider for them, has to implement that interface of when you plug into this interface, what should you be able to do? And you're responsible for implementing how do you do those things. Starting with C# 8 and 11, there's some new features coming to interfaces. So far, Unity doesn't support those, so I'm going to skip over those, but links in the description to what are those new features and how do they work. A key thing about interfaces is we can very easily change out the implementation without affecting our other code. I'm going to refer to another video I very recently did about persisting data across runs of your game. I created something called an iData service. It was responsible for making it so you can save and load data for your game. Specifically in that tutorial, we talked about saving and loading data with the JSON format. It's not super important what it is, but the way that we implemented it was, the way that we save data, we just defined an iData service called data service and set it to be a new instance of the JSON data service. So the JSON data service implemented that iData service interface. And what we did in the JSON data service was define how do we save and load data from a JSON file. That maybe seemed like overkill for that tutorial, but if later on in your game you need to change from a JSON data format because it's not suiting your needs anymore and you want to move it to, a binary data format, all you do is implement a new binary data service that handles how do you read and write data in that binary format. And instead of instantiating a new instance of the JSON data service, you just instantiate a new binary format data service instead. The rest of your code stays completely the same, so it really minimizes the changes of where you're going to have to change if you want to change potentially large portions of your code. This is just one of the benefits of interfaces. There are several other ones, but this is a really common one that we'll run into a lot of times because we'll start with, hey, I need this particular implementation, so I'm just going to do that. Later on, we need to change that, and it's kind of really mangled into our code, and there's a lot of refactoring that needs to happen to strip that out and replace it with a different version. So the interface defines, here's what we can do. Each concrete implementation of this interface needs to define how do we do those things. Now we talked about both the parent class and the interface. Let's bring it back into the mono behavior and look at some examples of real Unity code that we have so far. Whenever we're implementing our scripts, we'll frequently refer to the transform property, which is defined, it's not exactly on the mono behavior, but for simplicity's sake, on the mono behavior itself. We've never in our own class defined a public transform. What we do instead is just do transform, right? Or this dot transform if we're feeling really specific. And transform isn't the only one, right? We have like game object, tag, name, a whole bunch of properties, and some functions like invoke, start coroutine, destroy, and several others are all defined either at the mono behavior or at a higher level. As long as we're talking about the higher level, it's important to note that anything that the parent inherited is also inherited to our child class. So as I said just a second ago, some of these variables aren't actually defined at the mono behavior. Maybe they're defined at the component or the object level. All of these are other Unity classes that have one layer of abstraction higher over the mono behavior. It's not really important where they come from because we're deriving from the mono behavior. So from our perspective, if it came from mono behavior or higher, it's not really important. So even if we subclass our own class that extends the mono behavior class, we'll have access to everything that the mono behavior has, as well as that class that we subclassed. But what defines if something is inheritable or not inheritable? That's where our access modifiers that we talked about in the very first video in the series come into play. When we first talked about access modifiers, we only talked about two of them, public and private. These are the two most extreme access modifiers. There's a total of 6. 3 of them in Unity you're probably not going to use, so we're just not going to talk about them whatsoever in this series. The third one that we're going to introduce is kind of in the middle of this, and it's called protected. So remember, private doesn't allow anybody to see anything. Public allows everybody to see it. Protected's in the middle. It doesn't let everybody see it, but it allows this class and all subclasses of this class to see this variable or this function. So this is really useful whenever we know that probably this is going to be required by our children to be able to reference it or to manipulate it to fulfill whatever we need to do. Or if maybe we need our subclass to call a function that maybe we were thinking about making private, but we know this is critical for any subclasses to also have access to, we might mark that as protected. The way I determine which access modifier to use is I always use the most restrictive access modifier. What I mean by that is everything starts private. Literally everything. If I define something, it is marked private until I know explicitly I need it to be more accessible than private for some specific reason. If I'm making strictly data model classes, probably I'll have public properties. If I'm making any mono behavior, everything is private serialized field unless I know a really good reason to make that protected or public. How do I determine whether I want it to be protected? Well, it starts private, and whenever I subclass that class for whatever reason, and I need to implement some specific behavior, only when I need to access one of those variables from the parent do I actually make that protected. And even before I do that, I'll think about, is this really needed by the child, or is there a way that this can be encapsulated into a function where the child doesn't need to know the internals of how that parent class is working? It takes a little bit of time to get used to this, but if you just approach it from make it private and then only expose it to a higher level as needed, you'll be pretty safe. The last thing I want to talk about with the access modifiers is, let's say that you make your parent class have a protected method that references some private variables. That's still okay, because remember that the parent class is the context in which that function is being executed, meaning that it knows about that private variable and it can still execute it. It's only when you're in the child class trying to access some variable or function that is marked private on the parent class directly that you run into a problem. Now let's jump into Visual Studio and, by practical example, get some hands-on experience with implementing an inheritance relationship between a parent and a child. Let's now take our AutoDestroyText class that we've been using so far and say that we want to retain that behavior, but also want a new variant of it that does not count down the text. Instead, for that one, we just want to keep whatever text it says on the screen and eventually have it destroy itself after that AutoDestroy time has elapsed. So what we're going to do is make AutoDestroyText do this default behavior of not counting down, because that sounds like extra behavior, and we'll create a child of the AutoDestroyText called CountDownAutoDestroyText, and have that one actually do the text updating. For simplicity's sake, I removed the Unity event. We're only using the onDeath delegate here. I've already created a CountDownAutoDestroyText class, and what we're going to do is go ahead and copy this update function because we want basically the same behavior. Let's just start, make sure we don't lose anything. And we're going to change it to, instead of extend mono behavior, we're going to make it extend the AutoDestroyText class. Once we do that, we'll see that there's two variables that we don't have access to, spawn time and text. So we might be tempted to go into AutoDestroyText and just make these two protected. That would resolve our problems that we've been having. On AutoDestroyText, we can simply remove text.setText, and we have the functionality working per our requirements. but we can see that we have some copy pasted code. If we need to come back here later and modify some of this stuff, I have to change it in 2 places. Maybe I forget about one, and then I'm going to hit some bugs about stuff not working the way I expected it to. So what if we have this update in auto-destroy-text be the base implementation of update, and we make countdown auto-destroy-text call this and then do whatever it was going to do before? To do that, we're going to make this protected virtual void update. It needs to be protected because our subclass needs to call it, and it needs to be virtual because our subclass needs to override that behavior. If we did not label this update virtual, this will still work, but we'll get an error back on countdown auto-destroy text telling us that we cannot override the update function because it's not marked virtual, abstract, or override. Labeling something virtual simply tells C# that this method can be overridden by a subclass, and that's it. With that, if we go to countdown auto-destroy text, we'll see that starts complaining at us that we are hiding the inherited member, and that's not what we want. So what we're going to do is make this a protected override void instead. Now it shows us that we are overriding the base implementation, and we actually first want to call our parent class version of update. We want to do whatever it was doing before. So we'll do base.update. You'll see if I mouse over base, it says that it's the class auto-destroy-text. You can think of this similarly to using the keyword this, where we're specifying we want to operate on this instance. Base references the parent class. To make that a little bit more clear, if I made an arbitrary new function here, we'll call it doUpdate, and I wanted to call update in this doUpdate function, what's going to happen is it's just going to call countdown auto-destroy-text update. In some cases, I might want to first execute the parent class or only execute the parent class's version of update. To do that, we'll just qualify update with base. You'll see now that it wants to call the auto-destroy-text implementation of update. In this specific example, because we're calling base.update in our update, the base update's already going to get called. The problem that we run into now is to set our text, we still need to calculate the remaining time. So while I can remove this bottom block, this line of code is still duplicated. Since it's duplicated in auto-destroy text, on our update, we can call getRemainingTime on the auto-destroy text, create a new protected float, getRemainingTime, that will return us the result of this calculation. On countdown text, instead of duplicating this code, we can directly say getRemainingTime in that string template where we're trying to set the text for the text. That way this calculation is only defined in one place on the parent class. So what's going to happen whenever Unity automatically calls update on any countdown auto-destroy text scripts is we're first going to do whatever we do in auto-destroy text, which is get the remaining time, make sure that we have some remaining time, set the game object to be active, and then invoke the onDeath callback. On countdown auto-destroy text, we're going to be first doing all of that and then setting the text to be whatever the remaining time is. It might make sense to put the text setting first. That way we set the text, and then if we get destroyed later, the text will read whatever it's supposed to read. So now we have 2 versions of auto-destroy text, one that works by simply keeping some static text and then destroying itself, and one that will count down. I want to take a second to give a huge shout out to all of my Patreon supporters. Every one of you is helping this channel grow, reach more people, and add value to more people, and that helps more people make their game development dreams become a reality. If you've been getting value out of these videos, consider becoming a Patreon supporter. Go over to patreon.com/LlamAcademy, get your name up here on the screen, get a voice shout out starting at the awesome tier, and some other cool perks at the tremendous and phenomenal tier levels. Speaking of the phenomenal tier level, I have Andrew Bowen, and at the awesome tier, I have Gerald Anderson, Autumn K, Matt Parkin, and Ivan. Thank you all for your support. I am so grateful. What I'm going to do is quickly update our countdown text prefab to use the countdown auto-destroy text instead of the auto-destroy text. I'm just updating the prefab to remove the auto-destroy text and to add the countdown auto-destroy text. Once I've applied all the changes to this prefab, I'm going to remove the countdown auto-destroy text and add back the normal auto-destroy text. I'll provide some default text on the TextMesh Pro text object and rename this to just say auto-destroy text. And then I'll create a prefab variant so we have 2 different prefabs, one for countdown auto-destroy text and one with the static text auto-destroy text. I made a quick change to our object spawner to allow us to have a countdown prefab and a static text prefab. So if I hook those up, you'll notice that they're both asking for an auto-destroy text, but I can drag both countdown auto-destroy text and auto-destroy text to this. And this is really important because the countdown auto-destroy text is an auto-destroy text with additional functionality. That's why we're saying inheritance is a relationship. Any derived class is assignable to the parent class, but the parent class is not necessarily assignable to that child class. Meaning, if on the object spawner, if I define these as countdown auto-destroy texts, I would not be able to drag the auto-destroy text prefab here, because a countdown auto-destroy text is an auto-destroy text, but an auto-destroy text is not a countdown auto-destroy text. Click play, it's going to spawn one or the other of these, and you'll see that both of these are behaving as we would expect. They disappear after 1 second based on our auto destroy time. Our text's died increments itself as they disappear. The ones that are countdown will count down, and the ones that say static text do not have their text updated. So that's a practical hands-on example of how inheritance works and how we can refactor our existing code to work with a parent-child relationship. Microsoft has some pretty good documentation about how does this work in C#, and I've got those links in the description below. If this is your first time dealing with inheritance, I would really recommend you go back through that last section again just one more time to really deepen that impression. I realized when I was putting this together that this is one of those kind of more complex topics that it takes a little bit to get because it was a little bit hard for me to explain it in a really simple way to you. With some practice, it will become very easy and you won't have to think about it very much, but it does take a little bit to get to that point. All right, homework time. Last week, we implemented an object spawner that raised spawn and death events, and it was a singleton class, or at least that's what you were supposed to do. You can see on the screen right now how I did this. I used the same object spawner we've been using, just converted it into a singleton and made the object spawner itself raise those spawn and death events, having the auto destroy text still raise the death event like it was, and then propagating that event to whoever subscribed to the object spawner death event. And of course, on the object spawner, we know when it was spawned, so we can just raise that event ourselves. To kind of close the loop on making a fully working demo, I created a new class called runtime GUI that just had a button. Wherever we click on that, it would call object spawner.spawn object, and we'd print out a console log whenever we spawned an object and whenever that object died. This one was a little bit trickier because you need to catch that event from the auto destroy text and then propagate it out yourself from the object spawner. But this week, we're going to break off kind of what we've been doing so far. We're going to go into a little bit more depth where you're going to have to think about it a little bit more, but I think we're going to come up with some really good results. And I think you're going to learn a lot going through this process. What I want you to do is imagine we're making a game where we're going to have enemies that come and attack us. Let's say that those enemies are, let's say there's 3 kinds. Let's say there's a melee enemy, a ranged enemy, and a boss enemy. What I want you to do is take everything we learned today with our inheritance and our interface knowledge and come up with a design for your classes for how does an enemy, how does the ranged enemy, and how does the boss look. Think about where you can go and create parent classes. Think about where you can make interfaces and show me these classes. Maybe send me a link on GitHub to your repo with all of this data modeled out, and also think about which classes need to be a mono behavior and which ones don't need to be a mono behavior. Remember that our goal is to make it so we can add new types of enemies or bosses without having to totally redo our entire application. We are starting today with only 3 enemy types, but maybe in the future we'll have more. So think about really what constitutes an enemy, a boss, a ranged enemy. What properties do they have? What interfaces maybe do they implement? Where does it make sense to group stuff into a parent class? And where does it make sense to make a child class that overrides the behavior of the parent class? I know this is a lot more involved than what we've been doing so far on these homeworks, but I really think that this is gonna really ingrain this into your head where it's really gonna click at the end of this. If you got value out of this video or the series so far, and you know somebody else who could possibly benefit from it, go ahead and share it with a friend. Let them know that, hey, you're getting value out of the series and that you think that this would really help them as well. It wouldn't also hurt if you would like and subscribe to help the channel grow, reach more people, and add value to more people. This new video is posted every Tutorial Tuesday, and I'll see you next week.